Okay, so lesson 3 today, we're doing solving quadratics by completing the square. What we're going to do on Thursday is we'll do solving quadratics by the quadratic formula. The quadratic formula is a really cool formula. It works for everything. But there's sometimes easier ways to complete stuff. So in this one here, how do you solve something like the x squared equals 64? How do you solve for it? You take the square root, right? Isn't that, what's the opposite of squaring something? You square root it. Okay, so if you square root x squared, you take the square root of 64. Now, we know that the answer is just not 8 anymore, do we? What is it? Plus or minus 8. There's actually 2 answers. Now, that actually makes sense with quadratics, doesn't it? Because most quadratics where it crosses will cross the x-axis at 2 points. Isn't that correct? A lot of the ones we do, right? There's the ones that are above it or below it that sometimes don't cross. So what we can do is we can actually take some of this information and use it to do some questions. Okay, hang on. Let's do this first one here. Let's do this first. Example 1. Why is this not fitting on a page? Okay. So we got what we have is a widescreen television set. Right? They're all widescreen now. But how do they measure the actual measurement for the television screen? Is it the width? It's the what? It's the diagonal, right? So when they say a 42-inch TV, it's 42 inches on the diagonal. Yeah, that's how they measure TVs.
Why would they make it look bigger?
Well, which is the longest side of a triangle, of a right-angle triangle? What's the longest side of a right-angle triangle? The hypotenuse. Isn't the diagonal the hypotenuse? Okay. Hey, what's cheaper? $20 or $19.99? $19.99 cheaper. Does it sound cheaper?
Sounds like way better.
Yeah, but it's only like 1/10 difference, right? It's the same with televisions, right? The reason they measure is on the diagonal so the TV sounds bigger when you buy it. Okay. So let's draw a little picture here. Draw a picture. All right. No, that's not a rectangle. Hang on. Thank you. All right, so here's our rectangle. Okay. What is the diagonal on this? The widescreen television has a diagonal measure of 42. So we can draw in here. If we draw a line from one diagonal to the other, there it is. What's the length of that diagonal? 42. Okay? The width of the screen is 16 inches more than the height. Okay? So if h is height, how do we mathematically talk about the width? H plus 16. Isn't that right? Didn't we just say the width is 16 inches more than the height? Now, do you understand why we're using h's and not h and w? Why? Yeah, it's easier to solve mathematically if you have one variable and not two. I know it surprises me too sometimes. Right, so we have h is our height, and in this case, the width is represented by h plus 16. Okay, now, is this a right angle triangle? Can I put a little box in this corner? It is. Most times you look at a TV, they're pretty hopefully not slanted. If you're buying a TV that has a slant to it, it's probably not a good TV. Okay. How do we solve for h? Pythagorean theorem, right? Isn't that correct? If we have a right angle triangle, is it the rules that the two shorter sides, if you square them and add them together, will you get the square of the longer side? Isn't that Pythagorean theorem? Yeah. So the formula is h squared plus, what's the width? H plus 16 squared equals 42 squared. Doesn't that work out that way? Isn't that Pythagorean theorem? Yeah? Yeah, it is. Pythagorean theorem. We can actually solve for this. Now, how do we solve? What do we do? What? Square it out so then you get a bunch of numbers, then you can get a trinomial, right? Yeah. We're always trying to get a trinomial in this case, because if we get a trinomial, we can do a bunch of things. We can either factor it, or we can complete the square, or what we're going to do in 2 days is quadratic formula. Okay, let's factor this out. You guys should be able to handle this pretty quick. H squared is just h squared. Okay, that guy, h plus 16 squared. Guys, that's not Remember, you got to FOIL it out. It's two binomials. H squared plus 32h plus what's 16 times 16? What is it? 256, thank you. Equals what's 42 squared? 1764. Okay. Did I skip a step there? Did I combine my two 16h's in the middle? You'll get better at that as you go along. Now what do I do? Do I bring everything to one side? If you want, actually, what did I do in this case? No, actually, we're going to do it slightly different. I got a different way of showing you completing the square. This one works out really, really well. Okay, let's leave the 1764 on that side, but is there anything we can combine on the 2h squares, right? Or the h squared. So we end up with 2h squared plus 32h plus 256 equals 1764. Now let's move the 256 also. How do we get rid of the 256? Subtract 256, so you subtract 256. Okay, one more line here. 2h squared, plus 32h equals 1. 5. 1508. Now, how is this different than the trinomials we've been doing in the past? It's not equal to 0, right? If we made it equal to 0, we could actually solve for the x-intercepts. But in this case, we left the number on the right-hand side. Is that correct? Yeah. Yeah, it's just a different way of doing it. And this is actually a common way to do it. You'll see it. In some cases, it will be easier to do it this way. Now, what do you think the first step in solving this is, after we've got this part of it? That would probably be a good idea. Get rid of the number in front of the h. Right? So if we get rid of the number in front of the h, how do we get rid of the number in front of the h? What do? You take the whole sucker and you divide by 2. Is that correct? Take the whole thing and divide by 2. You could do that, right? You could put a line underneath if you want, or put a line underneath each one. But, I mean, you can do this in your head. What's 2h squared divided by 2? H squared. What is 32h divided by 2? 16h equals. What's, 1,000 cut in half is 500. 500 cut in half is 250, so 750. What's 8 cut in half? 4. So 754. Okay, well, it's not bad. We're simplifying it down a little bit quicker, a little bit easier. Now, you can't. There's no 16 in front of the h. No. Now what we're going to do is we're going to complete the square. Now, when we completed the square in the past, all of it was on the same side, wasn't it? When we completed the square. Now we have some on one side and some on the other. So one part of the rule is going to slightly change, but it really doesn't change that much. What number do we, if we want to complete the square, okay, I'm going to make myself a little bit of room here. 16h, right, equals 754. Now, completing the square, if I want to add something here, right, remember when I completed the square, I put in the 2 lines? I'm also going to do something here. The only difference is what's in between these now. An equal sign. And previously, weren't they both on the same side? One was inside the brackets, one was outside the brackets. Big deal. No really fancy stuff here. Now, what number are we going to take to divide by 2? Remember this? We've got to figure out, we take the 16, right? That's still the same. So we take the 16, and we're going to divide it by 2. So what's 16 divided by 2? 8. We're going to take that 8, and we're going to square it, which is 64. Okay, now watch. This is where it gets a little tricky. If I add 64 here, in the past, because they were both on the same side of the equal sign, if we added 64, then we minus 64, right? Because it had to be in balance. This is different because of the equal sign. Why do you add 64 on both sides? Do you see how that changed? Right, in the past, we added and subtracted, right? But because they're on opposite sides of the equal sign, if you add 64 to the left, you add 64 to the right. You see how it's slightly different? It's still completing the square, but we've changed the way it works. Okay, so we add 64 here. Oh, cool. I like that. Yep. Is this two binomials? So h plus 8, h plus 8 equals, can you do this part? 8 what? 818, okay. No, well, you know what, I'm gonna combine this because, you know, I want to save myself a little bit of room because I'm lazy here. There we go. Okay. Hey. Okay, so now you're looking at this and you're thinking, well, I still got to solve for h. But when I gave you at the top of the page here, where was it? Way back here. When I gave you x squared equals 64, what did you do to both sides? You square rooted it, right? And you ended up with a what? Plus or minus? How do I solve for h right down here? What do I do? Do I take the square root of the left and the right-hand side? What's the opposite of squaring something? Square root. Okay, so I'm going to take the square root of this side. I'm going to take the square root of this side. Well, that's not that bad. What's the square root of h plus h squared? H plus 8, right? It's whatever is in the bottom part. Okay? What's the square root of 818? Is it a nice number? No. But, is there a positive and negative? Is there a positive square root of 818? And is there a negative square root of 818? Yeah. So to do this, what I do is I go plus or minus square root of 818. Right? I'm not to the stage where I actually want to put it in the calculator and get me a number because it's kind of ugly right now. Is h by itself? What's attached to it? A plus 8. How do you get rid of that plus 8? A minus 8. Okay, so basically you're moving it to the other side. So h equals negative 8 plus or minus 818. Is that correct? All we're doing is moving stuff around. What's wrong? No, it's not bad. It'll, by the fourth example, it'll make way more sense. Okay. Now, guys, what does the plus and minus mean? One could be plus square root of 818, and one could be... So is that basically two answers? So could we do that? Could we actually calculate it out? Now we're actually going to do the calculation. Here's one answer, here's the other. So h equals negative 8 plus the root of 818, and h equals negative 8 minus the root of 818. Two possible answers in this case. Okay, do the math for me. Give me an approximate to one decimal place. Hang on. I want everybody to do it, so just... I want approximates to one decimal place. You should be able to do this in your calculator. Do you not have a calculator? You need to buy yourself a calculator. What did you get for the first one? One decimal place. So go negative 8 plus the root of 818. And then the other one is negative 8 minus the root of 818. What'd you get for the answer? You have to do it. Wrong, but anyways. Do you even know which one he's talking about? You got negative 36.6 for that one? No. Could you actually do this with your calculator, please, instead of just guessing? What'd you get? 20.6. Okay. Okay. You add 20.6 and negative 36.6. Those are two possible answers. That one's possible, right? The left one's possible, right? We're trying to find the height, guys. We're trying to find the height of the TV screen. That's what we're trying to find. Could the height be 20.6? Can't be negative. What's that known as? I called it a name the other day. Extraneous. Oh my goodness. Yeah. So it can't be this. This is known extraneous root. right? It's an extraneous answer. Now, we need to have, hang on a sec, we need to have that number because do we need to be able to solve this mathematically? Yeah, you need that number to be able to solve this, but it's a useless piece of information. Yeah.
But 36 plus
Okay. But we talked about that. Sometimes it'll work out that even though it's the negative, it'll be the spin on it. Okay, so what are the dimensions of this actual TV? So the height is approximately 20.6. What's the length going to be? So it's approximately, what was the calculation? 20.6 plus 16, which is 36.6. It's interesting that it works out that way. Will it always work out that way? Oh, this is in inches, isn't it? No, it doesn't.
For all 42-inch TVs, that's the dimension.
That's the dimensions of the screen, right? Sometimes they put a border around the outside. Now, you guys know, you've heard of aspect ratio, right? Widescreen TV is 9 to 16. Have you ever heard that? Or like when you go to a movie, there's an aspect ratio, the dimensions of the screen. That's what they're talking about this.
What's the dimension of the movie theater screen?
No, I don't know. Go measure it.
Like writing everything.
Okay. So let's try to complete the square again. Now, guys, these completing the squares that we're going to do are going to get ugly. These completing the squares are going to get ugly. It's going to start to get harder. But Thursday I'm going to show you the quadratic formula, which works. It looks hard, the quadratic formula, but it is so easy. Because it's just a formula and you just add numbers in. Well, we'll see what happens here. Okay. We have x squared equals 3x plus 4. We're going to complete the square. But the difference is, guys, we're going to not make it equal to 0, we're going to leave the 4 on the one side. That's the difference this time. Yeah, okay, so what do we have to move first? We got to move the 3x. Is that correct? Minus 3x equals 4. Now, why did I leave space here? Okay, we're actually going to complete the square. Now, this is an ugly completing the square because you're going to end up with a fraction. Have we seen those? Not really. Oh, relax, guys. It's not that scary. It does take this is pre-count. We're talking, a question now takes a page. You'll find by the end of the semester, you'll be doing a page per question. Will there be a lot less questions? Well, of course. Okay, what number are we dividing? No. We're not dividing 3, we're dividing negative 3. Come on, guys. So negative 3 divided by 2, and we're going to square it. Okay, now guys, are you going to take negative 3 divided by 2 and turn it into a decimal? No. Leave it as a fraction. Yes, it's negative 1.5, but then you square that, that's an ugly looking number. It's useless to do it as decimals. No, it's not. That's timesing it by 2. Okay, now think about this for a minute. Guys, what's negative 3? Basically what you're doing, and if you wrote this out, right, this is what you would normally write out, and I said not to do it, right? This is what you would normally do. I don't want that. I don't want it as a decimal. Leave it as a fraction. It makes way more sense. Okay? Now, this may seem redundant to you, but what I'm going to do is I'm going to actually write it out one more time. I'm going to write it out like that, because we normally have 3 steps there, don't we? Right? We normally do this. If I gave you a question, and if I gave you 4, you would normally do 4 squared, and then do 2 squared, and then do 4, right? There's normally 3 steps, isn't there? I want to do that because it'll keep you organized. But I don't want the negative 1.5. I want the negative 3 over 2. Now, what's that as an answer? What's negative times a negative? What's 3 times 3? 9. What's 2 times 2? 4. Okay. Ran out of room there, didn't I? I'm gonna combine this, make it a little smaller here on the side, just so it doesn't make. So negative 3 over 2 squared is negative 3 over 2 squared, which equals 9 over 4. What's 3 times 3? What's 2 times 2? 9 over 4. Okay, that's what you're doing. Oh, what's negative times negative? Positive. Don't do that. So now, if I add 9 over 4 here, now, careful with this one. Because it's on either side of the equal sign, if I add 9 over 4 here, what do I got to do this side? Add 9 over 4. Do you see what, it's different than the way we've been doing in the past? It's not ridiculous.
You're ridiculous.
I know. Okay, so let's do the binomials. X and X. Right, now guys, the reason I did 3 steps, because we always look over here, right? The reason I do 3 steps is we can go right to the number and figure out what it is. Go to the middle one. What is it? So, minus 3 over 2, minus 3 over 2. Right? That's the reason I did that, for those steps. What's 4 plus 9 over 4? 4, guys, it's 4 over 1, right? 4 is 4 over 1. Make it to a common denominator of 4. 16 over 4. So 16 over 4 plus 9 over 4 is 25 over 4. You see, it's fractions, but the steps are still the same, right? That hasn't changed. How could you reduce that fraction? You mean like change it to a mixed or what? No, don't. You'll find, guys, don't change up stuff to decimals. Don't change stuff to mixed. Leave it the way it is improper fractions. Way easier. Yep. Okay, what's the next part? X minus 32 squared equals 25 over 4. Is that correct? Yeah, we just combined it down. Oh, yeah. Yeah? Okay, guys, now what do you do next? What do you do next? Square root of both sides, right? Is that correct? Okay, so what do you end up with on the left? X minus 3 over 2 equals plus or minus. Guys, what's the square root of 25? What's the square root of 4? 2. Now, do you understand why I left it in that form? If you changed it to a decimal, you'd have a really ugly number. You'd have, what, 6.25 or something like that? That's 6.25, right? Horrible. That's way easier to work with. Now, how many possible answers are in this case? This one plus that, and this one minus that. Okay, so first off, let's move the negative 3.2 over to the other side. So x equals 3 over 2 plus or minus 5 over 2. That looks weird, but it really makes sense, right? 3 over 2 plus 5 over 2, or 3 over 2 minus 5 over 2. That's 2 possible answers. So then what I'm going to do, I don't know if you notice I kind of do the same thing every time. Do I break it into pieces? Yeah? X equals 3 over 2 plus 5 over 2. X equals 3 over 2 minus 5 over 2. You guys will see this. It's the exact same steps every single time. It doesn't change. Okay, what's 3 over 2 plus 5 over 2? 8 over 2, which equals 4. What's 3 over 2 minus 5 over 2? X equals negative 2 over 2, which is negative 1. Well, those are really nice answers, aren't they? For having to deal with fractions, are those really nice answers? Nope. But here's the thing. Could there be an easier way to do this question? You guys are learning at least. That's good. Guys, what's going to happen is when we're finally done all this quadratic stuff, I'm going to show you probably 4 possible ways to solve quadratics. What you're going to have to do is you're going to have to decide which method you want to use. Some methods are easier than others to use. Now this one, it depends on the question. And you have to kind of look at the question and decide, I'm going to try this approach. Now, the quadratic formula, which I'm going to show you on Thursday, will it work for everything? Yes, it does. It works for absolutely everything, 100% of the time. Are there easier ways to solve? Okay, now watch. I want to show you something. Just little side note here, like, as soon as I show you this, you'll probably beat me up or something, but who cares? What's the original question again? X squared equals 3x plus 4. What can I do with this thing? You could try to factor it if you wanted to, couldn't you? So if we want to factor, do we bring everything over to the left side? X squared? Or bring it all to the left side? Minus 3x minus 4 equals now 0. Just try this one for a sec. See if you can factor this. What times what gives you x squared? That's negative, so the signs are different. What are the factors of 4 that when subtracted give you 3? 4 and 1. And we want it to be x minus 4 equals 0. X plus 1 equals 0. What's x equal? Okay, that's exactly it. Would that have been way easier? Was that what we got before? Because we need to practice on completing the square. Yes, you know what? Okay, that's the point I'm trying to make here. It doesn't always work, right? You're not always going to get a question that works out this way, so you'd have to go back and complete the square this way, right? No, what's going to happen is when I start showing you these questions, I'm going to tell you, hey, solve this by completing the square. Hey, solve this by factoring. Hey, solve this by using the quadratic formula. I'm going to tell you off the start. But then what's going to happen is, let's say on the test, I'm going to give you a question. You can solve it any way you want. If you use, let's say, the quadratic formula, you're going to be there for a few minutes. If you factor it, you might only be there for 30 seconds. Right? That's part of knowing this stuff. And you'll see as we go along, it'll make a little more sense as we go along. You'll get the answer right every time. But there's multiple ways to get there. Just like graphing. No. Graphing, are there multiple ways to graph something? Table of values, right? Can you find the vertex 2 different ways? Yeah, negative b over 2a or vertex formula, right? There's multiple ways of finding stuff. You have to decide. No. Okay, next one. Okay, find the zeros.
Which means find the x-intercepts.
Basically find the x-intercepts or find the solutions. Okay? Now, it says this is interesting. State your answers as exact values, which means I don't want any decimals. And I don't want those decimals to go on forever. If it's, for instance, would you give me 0.3 repeater or would you give me 1/3? You'd give me 1/3. Is that more exact? Yeah. Okay. So, there's our quadratic. Negative 2x squared minus 5x plus 3 equals 0. What we're going to do in this case is we want to solve it by completing the square. We're going to solve it by completing the square like we've done for the last 2 questions. So we're not going to make it equal to 0. We're going to make it equal to, not plus 3, minus 3, right? Because we're going to move it to the other side. Okay, so let's do that for starters. So we go negative 2x squared minus 5x equals negative 3. Okay, there we go. So to divide by what? Negative 2. Why do we have to divide by negative 2? Because we want to we want x squared by itself, don't we? Isn't that kind of the rules that we're going along here? We want to get x squared by itself? Yeah. This is where we're going to end up with another fraction, which you guys don't like, but it doesn't matter. So we're going to take this whole thing and we're going to divide by negative 2. Okay? What? You can do that if you want. What's negative 2 x squared divided by negative 2? X squared. Negative 5 divided by negative 2. Positive 5 over 2 x. I'm leaving it as a fraction. I'm not converting it to 2.5 as a decimal, or 2.5 as a decimal, sorry. Nah, don't do that. Equals negative divided by negative, so 3 over 2. That's not bad. I mean, they look kind of ugly, but we can handle it with completing the square. Even if it's fractions, we can handle it. Yes, we can. Don't give me that look. Yeah, that's not bad. At least we made it positive. Okay. So now what we're going to try to do is we're going to take this, right? I'm going to add something in here, and we're going to add something over here. Isn't that correct? We're going to add something here and add something here. Does it make sense to draw those lines in? Does that help you keep organized? Yeah? Hopefully you're using that idea. Okay, now this is where it gets tricky. The last one was a number. It was an ugly number, right? We divided it by 2. This one's a fraction, and we're going to divide it by 2. Procedure's still the same. What number do you normally take to divide by 2 and then to square? Which number? What's in front of the x? So 5 over 2. What are we going to normally do with that? Divide it by 2, and then we're going to take that number and square it. That looks ugly, doesn't it? People hate fractions over fractions. But watch. You know if you don't like 5 over 2 divided by 2, you can write it a different way. 5 over 2 divided by 2. Is that correct? 5 over 2 times the reciprocal. Oh, well, that's easy. 5 over 4. So that equals 5 over 4 squared. Is that correct? And 5 over 4 squared is really easy to do, isn't it? What's 5 squared? So 25 over 16. Well, that's not bad, is it? That actually works out quite nice. We can handle that. These are all really nice fractions we're kind of working with. Don't get scared by that 5 over 2 divided by 2, right? If you have to, go 5 over 2 divided by, and then multiply by the reciprocal. Okay. So what am I adding here? Plus 25 over 16. Now, because it's on one side of the equal sign, what do we do to the other one? We do the same thing on the other side. So plus 25 over 16. Sorry. I wrote 26, didn't I? 25. Yeah. Everybody's a critic. Okay. So I know it's fractions, but can you do this stuff? Yeah. Could you get lost easily? Yeah. And that's why I'm trying to, do I do the same thing I do the same thing over and over again, right? I don't think I even change my steps. I try not to because I'm trying to at least give you the steps. Even if you don't understand the concept, could you follow the steps? Yeah. Just a set of rules. Okay, here we go. So we're going to break this into 2 binomials. So x and x, you don't even have to think about this. You just go back and look at the middle one, and what is it? So plus 5 over 4 plus 5 over 4 equals, we got 2 fractions. Well, this is something you learned in middle years, how to add fractions. You have to have a common denominator. In this case, they have to both be 16. So you times the 2 by 8, so what do you do with the 3? Times by 8. So that ends up being 24. What's 24 and 25? 49 over... Do you see how this is already working out? Because we're going to have to take the square root of that, aren't we? Actually works out quite nice. Right. We're going along. One more. Keep going. Which part? 4? Sorry, I wasn't very clear. Well, it's this middle part there. Plus. What's the middle one? I had a 4 there. I did not have a 7. Okay, anyways.
Can we do x plus 5 over 4 squared?
Well, that's what I'm doing right now. That's the next step, right, is to combine it down. Could you, if you wanted to, skip this middle step here? Yeah, some of you can already skip that step, but most of you need to actually do it. Okay. So now, what are we going to do? Right, we got to square root. Is it the same steps over and over again? Yeah, they haven't changed it. Square root left side, square root right side. Okay. X plus 5 over 4 equals, no, careful, plus or minus 7 over 4. Right? We can do that one. Yeah. Oh, sorry, go ahead. Either one.
What if like the number is one of the numbers of a fraction you can square?
Then you can't do it. You have to leave it as plus or minus the root of 49 over whatever it is. We're going to get to those ones yet. But these ones, have I given you ones that work out really nice? Yeah, that's the bulk of the ones you're going to get, right? They're going to work out nice. Yep.
I don't put the plus or minus.
You have to. You have to put the plus, yes, you have to put the plus or minus because there is the two different answers. We're talking about roots, right? So there's three options for roots. No roots, one root, or two roots. These are lots of twos. Okay, so let's do the next thing. So now what we're going to do, let's move the 5 over 4. So x equals, guys, negative 5 over 4 plus or minus 7 over 4. Now, I'm going to do my lines here. I do my lines just to keep myself organized, right? X equals negative 5 over 4 plus 7 over 4, and x equals negative 5 over 4 minus 7 over 4. Oh, this one's easy. Negative 5 plus 7 is 2 over 4, which is a half. And this one is negative minus a number is negative 12 over 4, which is negative 3. I'll move out of the way so you can help. Right, that's just the straight math, right? That's the two answers. Lots of steps? Incredible amount of steps.
You've done it the other way?
Could you have factored it? Oh, probably. I don't know what it would have been. What would it have been? So what were the answers? X minus a half is one of them, and x plus 3 is the other. So FOIL it. That's a hard one to get, right? You don't normally factor that. Yeah, this would have been easier in this case. All right, now let's do something with some decimals.
No.
Yeah. I do. I just don't like when you convert fractions to decimals in the middle of a question. Oh, relax. These are just examples. When you actually get to them, they're going to build along. They're going to start easier and then work progressively harder and harder and harder. Not when you start with the basic ones, okay? So here, this is from your textbook. And of course, it's missing part of it on the screen. I'll read it off of mine here. A defender kicks a soccer ball away from her own goal, right? The path of the kicked soccer ball can be approximated by the quadratic function. So think about this. It's a quadratic, right? So is it a big arc? Yeah, it goes up in the air and then comes down. Where the function is, and they give the function there. Where x is the horizontal distance traveled in meters from the goal line. Okay. So what we want to know is, yep. Yeah, we did it in a different format. Now we can actually do it by completing the square. Remember I said before we couldn't do this unless you had a calculator? Yeah, of course you will. Okay, so we want to know where it starts at. So we make it equal to what? 0. So let's do that. Oops. This is the first part. Let's make it equal to 0. So 0 equals negative 0.06 x squared plus, and I just changed it to x's, didn't I? Or was it already an x's? It's already x's. If you don't like the way it is, you can always change the numbers. Some people like specifically working with x's. Minus 35.34. No, we're not doing that yet. Now, we've made it equal to 0. But all three examples we've done so far, do we make it equal to 0? No. What did we do? We moved the constant to the other side, right? You guys remember the constant. What's the constant in this case? Negative 3.834. So what are we going to do? We move it to the other side. Okay, so it's going to be 35.34 equals negative 0.06 x squared plus 3.168 x. Okay? Same rule before, right? We did this before. We moved everything, we moved the constant to the other side. Now, what's the next step we did? Do you remember? No? What do we got to get by itself? What do we got to get? We got to get x squared, like a nice old x squared. So what are we going to do to this entire
Divide by-
formula? You're going to divide by negative 0.06, because won't that get rid of it? Yeah, okay, so let's do that. So we're going to take this whole sucker here, we're going to divide it by negative 0.06. Beautiful. So this is where you need your calculator, because you're going to have to put the numbers in there. What's the first one? Negative 589. X squared. 52.8x. Oh, actually, that kind of worked out nice, didn't it? It did. All right. So did we get x squared like it alone by itself, right? Is that what we did? Okay. Now, I'm going to write this out one more time because I want to put my little lines in here because I always forget. So negative 589, right, or whatever the line is, right, I'm going to add something in there. X squared minus 52.8x, and here's my other line right here. Now, why did I put my line on the right-hand side of the negative 589? If you put it on the other side, will you make a mistake? Yeah, you will. Do it the same every time. Is it always on the right of the number?
Could we change the negative 589 to the other side? But
Make it equal to 0?
no, like the x squared minus 2.8y equals.
No, because then it'd be negative. If you move this to the other side, it'd be negative. Oh, I see. You put the equals over on the right. Yeah, you can. But I did this deliberately this way so you can see it slightly different look at it. You have to get... It's one of the hard parts about math is, and I can show you a basic concept, and then I start moving things around, changing the way it looks, right? For instance, how many people like to write x equals a number? How many people does it really matter if it's 5 equals x or x equals 5? Does it matter to them? No. As you get better with math, you start to ignore that rule, right? Some of you will always put x equals the number. Some of you will realize it can go the other way, 5 equals x. You don't worry about the direction that it goes. If you want to, put it to the other side if it helps you. Okay, now, oh shoot, I've run out of room here. All right, I'm going to have to... Where am I going to do this work? Yeah, I guess, well, because I need to do the dividing by 2, don't I? Okay, normally I put that kind of to the left or right. I'm going to have to put it off to the side here and kind of skip some spaces here. What number am I taking to divide by 2? Negative 52.8. I'm going to divide that by 2, and then what am I going to do with it? Square. Okay, so what's negative 52 point, so that's negative 26.4, is that right? I'm going to square that. What do I get? 696.9. Sometimes this board is not wide enough. 696.96. Is that correct? Okay. Now normally I do that to the corner, right? I had to do it in the middle of the page here. Okay. So here's the deal. If I add 696.96 here, what do I do here? Add. Why do I add it on both sides instead of subtracting in this case? That's because of the equal sign, right? I'm doing it on either side of the equal sign. Yeah?
Yep.
Is it making a little more sense at all?
Oh, no, it makes sense. I just don't like doing it.
Oh, okay, that's a different story. Okay. I can live with that. Okay, what's negative 589 plus 696.96? What is it? I'm gonna skip that space there. 107.96 equals, here's my two binomials, x and x. Now I don't even have to think, right? I know I just look here at the middle part and it's negative 26.4. Negative 26.4, negative 26.4, right? Again, I haven't changed my steps. My steps are the same every single time. Okay, 107.96 equals x minus 26.4 squared. Hey, look what we're back to again. Do we come back to this every single time? Yeah, we do. Okay, how do we solve this now? What? One side? Both sides? What do you do? Both sides. Square root? Square root. Okay. So we end up with now. Better way, am I gonna take the square root of 107.96, or am I gonna do that as my final calculation? Final calculation. I'm gonna put plus or minus the square root of 107.96. Right? We'll actually figure it out in a minute. And this one is x minus 26.4. Okay. I want x by itself. So what do I do with that negative 26.4? Move it to the other side. So 26.4 plus or minus the square root of 107.96 equals x. How many possible answers? 2. So let's do it. Draw my line. There they are. Right? So 26.4 plus the square root of 107.96 equals x, and the other one is 26.4 minus 107.96 equals x. Now do the math for me. Actually grab your calculator, and do it. Put 1 decimal place. $36.8. And the other one is 16.0. Okay. Well, there's a good question for you. What if the question asks you to go to 1 decimal place? Do you put 16 or do you put 16.0? You put 16.0. If the question specifically asks, hey, write it to 1 decimal place, you put 16.0. That's the mathematical way of doing it. Some of you might say, well, why do I need to put in the 0? But it's not about sometimes that. It's about reading the question. It is more. Well, no. Well, there's a tolerance variable. Like we're talking about accuracy. Okay, now, what does this actually mean? What was it? Good. I'll scroll down a sec. Look at the original question. It said, "This is the defender kicks the soccer ball away from the goal." Now, normally you would assume that the goal line is 0. But how far away from the goal was she before she kicked the ball? 16. The ball went through the air and landed where? 36.8. Because those are zeros, aren't they? Aren't they the solution? So if you actually, guys, just take a minute, and if you actually looked at what this looks like on a graph, right? I'm just going to draw a quick X and a Y here, just so you can see. If it was straight, it would help. There we go. Okay, so she's actually how far away from the goal before she kicks it? 16. It goes up, and then it comes down. So this point right here is 16.0. This point here is 36.8. Okay? So she's 16 meters away from the goal. How far does the ball actually travel? So it's, what is it? 20.0 meters. So this part is A, that part is B. That makes sense?
20.3.
Oh, 20. Sorry. Right? Put a little snowman there. 20.8. That makes sense. Now, previously, how did we have to solve for these? Calculator, right? And I told you before, in a question like that, you actually plug it in and find the zeros. Can you actually do it mathematically now? Yeah. Okay. So, what I would recommend, guys, don't just close your books up. You have like 10 minutes. I would at least start the questions. The reason you want to start the questions is it in your brain? If you leave this till tomorrow, will you forget all about it? I guarantee you will. Okay? So do at least a couple questions. Yeah, you can work on that too, but do one or the two of these just to keep it fresh in your brain. And I will stay for lunch, right? So you can keep working on this. You can go get your lunch and come back if you want. Yeah, just hang on one second. Yep, yep.